Well, hello, and want to thank you guys for joining our presentation titled, How to Use Android Things to Build Successful IoT Devices. This presentation has been put together for you by NXP Semiconductors, Google, and Avnet. We want you to expect to learn how to use Android Things to enable you to create a professional product on a trusted platform. And using the hardware that's created by NXP and sold through and supported by Avnet, there's really no limits to the devices that you can create and the markets you can serve. My name is Michael Lamp, and I'm Director of IoT Solutions for Avnet based out of Dallas, Texas. Your presenters today are Vince Wu of Google and Robert Thompson of NXP. Vince is the Product Manager for Android Things and is based in San Francisco Bay Area. And Robert's with NXP and manages the IMX processor family ecosystem. Robert's based in Austin, Texas. I want to get started with a brief introduction of Avnet. Avnet is a global distribution partner of NXP, as well as many other companies that build SOMs, boards, and products using NXP technology. These include partners like Technection, Murata, and others. Avnet has over 40 locations in the Americas that are staffed with engineers and account managers. And our job is to assist you in bringing products to market. We do this by providing access to electronic components and systems, as well as supply chain solutions and design services. In addition, we support our customers with 4 other distinct businesses, including Hackster.io, which is a site to educate and drive innovation through collaboration. Another is MakerSource, which is a community focused on connecting customers with services that range from legal to design support. And as well as Element 14, our community for supporting electronic design and our suppliers' products. And finally, with Premier Farnell, we offer an online catalog for electronic components and devices. So in support of the presentation you will hear today, we have supplied many of our FAEs, our field applications engineers at Avnet with NXP's IMX processor kits based on Technection. And we want to demonstrate the capabilities of Android Things in person to you. So following the seminar, and assuming you want to learn more, I welcome you to reach out to your local branch of Avnet and request a demo from one of Avnet's FAEs. And now it is my pleasure to turn the presentation over to Mr. Vince Wu to present Android Things.
Well, hello and good morning, everyone. My name is Vince Wu, and I'm here today to talk about Android Things in more detail. I'm a product manager on the team, which means that most of my time is talking to developers and understanding what are the needs from you guys. But more importantly, we're here to listen to you in this webinar, and if there's some questions, please feel free to ask them, and we'll be sure to answer them and provide the feedback to the engineering teams. So Android Things is one of the new verticals that we've added to Android. So as probably everyone knows, we already have the phones and the tablets, and in recent years we've branched off into wear, into TV, into vehicles, and truth be told, people are already using AOSP Android to make IoT devices, and we thought there's actually quite some challenges in general for building these IoT devices, which is why we created a specific vertical for it and specific images to handle the IoT space. Let me go through a little bit about the challenges that we see, and this will sort of explain what are the differences and what are the specifics with Android Things. The first problem that we see is there is a fragmented developer experience when you want to build IoT devices. And what people really want to do is put their developer resources into a stable software stack, such as Android, stable APIs that you can build on top of, and be able to sort of move your services and apps that you build across devices. Scaling to the second problem is, of course, time to market and development cost for building these devices. Scaling to production volume is often very cost prohibitive for small to medium-sized companies. And even for large companies, there's a lot of effort and engineering involved with, sort of software bring up for new boards, getting the kernel and firmware ready, in addition to, of course, the interesting bits, which is what the device is actually for. And finally, security is very hard. It seems like every other day we hear about a big, attack compromising, for example, security cameras and whatnot in the space of IoT. And we thought we could do better with Android and provide automatic updates, etc. And I'll go into these in a little bit more. So first off, people often ask us, what is Android Things good for? And what sort of devices is it targeting? The devices that we are looking at are definitely the ones that require a little bit of processing on the edge. These are more powerful devices with intelligence. For example, you might want to be doing image or audio processing at the edge, and then uploading process information to the cloud for analytics or machine learning. So these are the type of devices that we're looking at. Or if you have many devices and you're aggregating data across multiple sensors and whatnot, and then sending to an edge device for display. So we're not talking about very, sort of low-end bare metal devices, of course. The basic requirements, just to give sort of a baseline, is, for example, you would have at least like 512 megabyte of RAM on these devices, and we're looking at devices with at least an A7 core on it. Now, what's interesting is, of course, what's different about Android Things and how is it different from AOSP. And let me go through a little bit about what the program looks like. So a little bit different from Android, it is not just purely about the OS. I'll hand it over to Robert in a little bit to talk more about the certified hardware, but that is a big component of how this program works. We work very closely with NXP, for example, and we bring up reference boards and specific SoCs that we already pre-certify and make sure that Android works well on it. On top of that, of course, we have streamlined Android specifically for IoT, and we'll go into a little bit about what we've done to streamline that. And then, of course, want to make sure that apps and services run very well on top. And increasingly, people are looking into things such as machine learning, Google Assistant, cloud services, and the like. And to wrap this all together, there is a developer and management console around it that allows us to deliver auto updates on the system software, and also to monitor for any stats that are interesting for developers. Now, going into the top level really quickly, so this is the services layer. As you would expect, this is Android, right? So Android Things is fundamentally full Android. So you should expect that you can leverage the full Android ecosystem. And this includes, of course, the Java SDK, the native NDK for it as well. You should expect that you can use Android Studio and all the developer tooling around it to build your apps and services on top. There is, of course, Play services. However, Play services, because we're talking about IoT, we did streamline Play services for it, so that the APIs that do make sense for an IoT device we've included, and the ones that don't, we've sort of taken out so that we shrink the image down quite a bit. Of course, people like to use Firebase for developing their apps, and you can use this with Android Things as well. And of course, things like Cloud Platform, you can use that, and you can connect to not just the Google ones, of course, but you can connect to competitors as well. Now, of course, when we're talking about the Android APIs, the reason why developers are usually very interested is because we've already done a lot of the work through the years to have a well-established stack for cameras, for audio, for sensors, and these are all things that people are interested in using for building things like smart cameras, smart speakers, etc. And you can leverage all of this work that has been done for phones and tablets, and now we can leverage all these APIs for all sorts of IoT devices. What's also new and recent is Android has been adding a lot of machine learning APIs, for example, computer vision, and sort of speech processing as well. And these are now all available because of Android things to IoT devices as well. Now going into the image a little bit, images in Android things are built and signed by Google, and these are made available through what I mentioned before, the developer console. What is interesting about the developer console, of course, is it is a tool for anyone, any developer, to go and download the image. And this includes all the BSP support that you would imagine that would usually come from directly from SoC. We've already taken this and put it into Google's tree, and we're basically providing infrastructure for building these images and providing them on the developer console. And we are guaranteeing that we will have security updates regularly, just like we do for the Nexus program on phones and Pixel programs on phones, so that the end user do not have to worry about sort of security updates. These new security updates will be made available on the developer console, and it's up to the developer, the OEM, to decide when to push these out. So we make these available, but it is at the discretion of the developer and OEM on when they want to push this out to their fleet of devices. So what this really means is that the developer, the OEM, really only needs to worry about the apps that are running on top, and they don't have to worry about anything from the HAL and kernel layer and below. We have signed images that come from Google, meaning that we are supporting verified boot with the AB scheme. What this means is that we'll block the device from booting into an unknown state. And the images are signed and the contexts are verified by Google. So we have things such as rollback protection, or if there's a bad actor sort of changing the image, we will make sure that it doesn't boot into it. And we can make sure that the system is always in a good state. What the AB verified boot scheme also means is that as the users are using their device, we'll be downloading the updates in the background into the B partition, so that the images, the updates are applied sort of automatically on the next reboot. And so there's no sort of time involved with the user sort of seeing the time required for updates and the required for updating apps and stuff like that. So everything sort of just works seamlessly when you reboot. Okay, so let me now move on to the SOM architecture. Android Things hardware, so the bottom piece, uses system on module architecture. And what this means is that we have a core computing module, in this case the NXP 6 UL, and we have all the other hard to sort of design components in a small package. This includes things such as the Wi-Fi, Bluetooth, etc. Let me actually pass this off to Robert at this point, Robert from NXP, and he can take you through a little bit more detail around the SOM.
Great, thanks, Vince. So when we started talking to Google and working with Vince's team about how do we enable faster production, easier prototyping, we suggested that what we saw in the industry to enable a much wider audience than Android was used to working with is to adopt the system on module approach, as you can see here. I'm sure many of you are familiar with this. If you look at the system on the module on the right-hand side, really what it does is it encapsulates, as Vince just listed, all the major design components in terms of the high-speed buses, DDR layout, and so on, that really extend the development and prototyping stage for most companies. Therefore, what we decided to do in partnership with both Google and our selected partners is work with these companies to develop system on modules that would not only allow customers to quickly prototype by including a baseboard, as you can see on the left-hand side, that exposed most of the major interfaces, but also making sure that the system on module consisted of components that were widely available in the market. Therefore, if once you want to move from prototyping into production, you can go back to the system on module manufacturer and order these order the modules in quantity to quickly move into production. Therefore, all the design you have to do as a customer is redesign the baseboard to the XY dimensions of your product, design some casings, and really try and make sure that not only was the hardware as simple and straightforward as possible in terms of designing and getting to market, but also that we worked with Google to make sure all Android things run as they wish by making sure it was pre-certified. So if we go to the next slide, we can see where we are today in terms of certified modules. And I've included all of them. Obviously, some are not on XP, just for inclusion. As you can see there, we have worked with Vince and the Google team to certify 3 NXP-based systems on modules. They are currently based on the i.MX6UL, which is a single-core A7, and the i.MX7 Dual, which is a dual-core A7. Both of them are based on the same architecture, and as you can see there, they both, all the modules are based on the same core configuration, which is the configuration needed to run Android things in an efficient manner, but with not adding extra memory to make sure that the modules are very cost effective and allow you to design a product, an end product, which will be cost competitive in your final market. So if we go to the next slide, I'll talk about a couple of these in detail. So the one partner we've worked with is Technexion. They have actually had 2 modules qualified to run Android things. The first is the Pico i.MX6UL. As you can see, the features that I've listed, key features, in terms of memory, it's exactly the same for both modules. The Wi-Fi is different. The 6UL, as you can see there, is based on an 802.11n module. The 7D goes to an AC. That's looking at different usage models. So if you're looking at using both 2.4 and 5 gigahertz, you can look at the 7D. Same PMIC. And then if you look at the overall baseboard design, we really worked with both Google and Technexion to replicate the Pi form factor and the expansion header. So this board is compatible with Pi accessories. We also have another expansion header from a company called MicroE, and it can take over 200 clicks, therefore allowing you to very easily add different modules and peripherals, such as GPS or different sensors, to really enhance your development and prototyping stage. Now, these are both low cost. As you can see there, we focused on providing the kit. That is the price for the entire kit. And these are available today through Technexion and Avnet. The other thing to understand is that both the 6UL and the 7D are pin-to-pin compatible. So you can buy one kit. And if you want to prototype with a dual core as opposed to a single core, you can go back and order the SOM by itself and not have to buy 2 kits. As you can see there, I've added some logos in the bottom right-hand corner. And Vince might talk about this. I think he mentioned the value-added services. So this board, we've already tested it, and it demos the Google Assistant and Chromecast built in. So this board is a very powerful prototyping kit. It's available today, certified to run Android things, and you can buy it both through Technexion and Avnet. One of the other boards I'd like to highlight that is actually coming soon, if we go to the next slide, is based on the same NXP part, the i.MX6UL. It has the same configuration on the system on module because that's what is needed to run Android things. And this was developed by Murata. Again, this will be appearing on the Android Things website beginning in August as a certified module. It's not there right now, but it's coming soon. And again, what we've tried to do is we've tried to work with a number of different partners to make sure that we have worldwide coverage, and also for you to compare the different partners we have. Their pricing is very similar. But again, we're focused on not just enabling you to prototype but to get you into production as quick as possible. So if you do prototype based on any of the NXP-based modules, you can then go back to either the partner that you selected for the development kit, or you can go to the other partners and get quotes from them to purchase these modules in larger quantities, from thousands to hundreds of thousands. These will all be, as you go, as we said, currently we have 3 modules which are available. All of those are in mass production and can go into volume production right away. The Murata module I'm showing you right now, Vince's team will finish certifying by the end of the month, and the image will be available, and this will be available through Avnet by August. Okay, that's a little bit of a dive into the details of the hardware. I'll hand back to you, Vince, to continue talking about the software side of things.
Thanks very much, Robert. That was really great. When we talk to developers, a lot of them really like this model because they see a path from prototype all the way to production. As you saw from what Robert shared, when you first start out, you start out with a small breakout board for development purposes, where it breaks out all of the buses. And this is really easy to just sort of get going, and you can run a bunch of services on top that already work and prototype your design that way. And once you get into production, what you can do is, of course, redesign it or even relay it out so that you reduce the costs. The image, just to reiterate, comes from Google. So the Google managed software, of course, includes the board support package, and you guys can rely on that. And all the updates, the ongoing updates for security, also come from the developer console as well. So this makes it really, really easy to go from prototype all the way to production, and you see a path for the whole thing. Okay, so let me go into a little bit about Android things and what we did to the Android framework to streamline it for the IoT use case. So what I'm showing you here is of course the typical stack diagram for Android. So at the very bottom we have the kernel, and then we have a bunch of the Android libraries on top, and then the Android application framework, and then finally we have the apps on top as well. So when we took a look at this, and we also talked to people that are using AOSP and then building IoT products and what they need, what we did was we went ahead and removed the parts that are not really that relevant for IoT products. So of course, the upper layer user-facing apps are not super relevant for IoT because, of course, you don't really expect the user to go to a Play Store and install various apps. And also a lot of the default apps don't make sense either. So this by and large reduced quite a bit of the footprint that we have. The other part that is interesting is the visual framework components. For example, the system UI. So a lot of these things are not really that relevant either, and we were able to make them optional. A lot of the assumptions around end users will be installing apps on the go and needing to grant permissions, etc., don't really make sense, because for a lot of IoT devices, there is no UI for people to grant permissions. No way to say, click OK on a dialog box, etc. So all in all, we shrunk this down by about 50%, and this is sort of the core baseline for IoT devices. Obviously, displays are optional. Android Things does support the same UI toolkit, so you can make devices with displays. The only difference is that now you have the option of building them without. The way it works is that the applications that are run on Android Things have full control over the display. So when you first boot up, it basically startups the app that you designate as the primary app. All of the input events go to the foreground activity. So the app that you designate has focus. And of course, when you build these apps, all of the standard Android idioms are used. So there are activities, there are background services, etc. Most APIs that involve showing a dialog or require a view to the user, we have made optional. And so there are different ways of granting permissions, etc. let me delve into permissions a little bit because that's often a question that comes up. So all of the install time and runtime permission checks are granted on startup because the assumption is that the OEM developer has full control over this device and is deciding which apps run on it by default. And therefore, all of the permissions that it requires are granted at boot time. So that's not something that the end user needs to grant in the UI. So obviously, without a display, it's a sort of a different paradigm. So how do you actually interact with this device? So you can consider using voice. You can consider using sensors and game controllers, etc. There's all sorts of things that you could do without a display. And the good news is, of course, the Android SDK already provides support for all of these alternate ways of interacting. So this is not like low-level support that you will need to add. Let me go a little bit into the code a little bit because I think this makes it much easier to understand how things are working. The first thing that I'm showing here is how do you designate, how do you even set this up? What app is run at the beginning when you boot up Android things? So what I'm showing here is the manifest for the app that you designate as the one that shows up on top, that is auto started at the beginning. So what you would do is you would add the Android things support library at the top, and this is hosted on JCenter. So it's sort of one line inclusion, very, very easy. You declare the SDK dependency on top, and then you put the user's library tag so that it knows to use this library. And then finally, there's a intent filter here that sort of says, okay, this is the main app that should run and should be auto started when Android things boots up. And this is how you hook up your app. And just to reiterate, there is no system UI, so there is no assumption that the user, when they boot it up, they would see sort of the system UI on all the apps and the Play Store and all of that. This is basically full control from the IoT developer, and their app is the one that controls the entire screen. Of course, it is completely flexible in terms of how the developer wants to organize their code. They can have multiple apps, they can have background services, they can do all sorts of things to structure it the way that they like. Let me talk a little bit about hardware control. Of course, Android proper does not traditionally have APIs for controlling, down to the hardware layer, the standard communication buses. And this is the main API that we added to Android things called the peripheral I/O library. This allows you to connect the lower speed components to the module. For example, things such as buttons, relays, so things that usually involve GPIOs. This also includes things like servo motors, speakers, LEDs, things that are usually PWM. More complicated things like displays or sensors, advanced peripherals. These are usually I2C or SPI. So we support all of these things, and of course with UART, you can connect things like GPS, printers, RFID readers, barcode scanners. So really the assumption here is that we want to support the broad proliferation of IoT devices out there. Whatever people come up with, you should be able to connect these in and then control them from an Android app. So this is some sample code explaining how this will be done. This is the most simple example, which is a button with control over GPIO. Basically how this works is that at the very beginning, you explain, you basically hook up the GPIO that you want to connect to, and then you have a callback for what to do, whichever event you want to handle. So in this case, this is the GPIO edge callback, and then you can do your app processing there. And as you can imagine, we have similar APIs for the other buses, I2C, SPI, etc. We also have a notion of user drivers. And the reason why we have this particular notion is Android specifically already has a bunch of support libraries for handling inputs and sensors. And oftentimes you want to hook up to the callbacks that are available there. So for example, for input, there's already an Android input framework, and obviously, you know, developers ask, well, if I connect a keyboard or something that looks like a keyboard, how do I make sure the events get plumbed through and then the right callbacks get called in my app? Same thing for sensors. Android already has a sensor manager that handles a lot of things such as power management and making sure it you know, asks for sensor updates at the right time and putting things to sleep and stuff like that. Same thing for GPS. So the user driver is a way for you to hook up the right things into the Android framework. The reason why we had this diagram this way is, of course, you can you can access the peripherals with the peripheral I/O directly, but oftentimes you want to hook this up to the Android system as well. So this is sort of an additional thing that you might want to do. So this is an example code for how this would work. So you have the user driver manager, and you hook this up, and in this case, you tell it that you want to handle the space on the keyboard, and this gets called back, and you get the callback when the user, you know, presses the space. Let me move on to the peripheral driver library, which sort of pulls all of this together. Because as you can imagine, if you have a lot of peripherals that you attach, and you might not want to write all this code by hand. What we also added is the peripheral driver library. This library contains pre-written drivers for a lot of the common components. This is hosted on JCenter, so you can just pull this in with one line as well. And if you have any, we also accept suggestions and code from the developer community as well. So if there's new drivers that people want, we keep on adding this to the driver library as time goes on. And just to give an idea of how different this is, this is the same thing, but using the peripheral driver manager. But the button input driver is something that's part of this library, and this is how you would hook this up. One line, easy peasy, instead of having to write the long list of boilerplate code that we saw earlier. So I guess in summary, Android Things enables developers to use the power of Android. So this is full Android. You have all of the APIs that you would expect, all the system services, etc. So and all the tooling and all the developer tools like Android Studio around it. So to the extent that people already have investments in Android, this is very easily transferable. These BSPs are managed by Google, so you don't have to worry about security updates. And we have compatible hardware that we've worked with NXP on, so you can just buy one of these modules and rest assured that Android already works turnkey on top, so don't have to do any of the bring up work. And finally, we have the IoT developer console, so that everything is automatic in terms of the end user experience. They buy one of the products during production, and devices keep on auto updating as time goes on. So that concludes the material that I had. I'm just going to throw up a couple of links up here in case people want to access more information. The first link is our developer community. This is where people ask questions, and a lot of our developers and community often answer these very quickly. This is the IoT.google.com is the general Google link for everything. And we also have a specific developer site for Android Things specifically that you will find more information on. So with that, let me hand it over to Q&A.
I guess. So thank you very much, Vince and Robert. Right now, we wanted to open it up to questions. So please use the questions feature in our conference tool. I've already received some, so with that, I'm going to go ahead and start asking Vince and Robert some questions that you guys have asked. So first, I think this is most appropriate for Robert. Robert, how does Android Things support the use of the M4F processor in the IMX7? I've noticed that there's an IMX7-based Pico reference board for Android Things.
Yeah, thanks. Good question. So currently, Android Things, as the solution that Vince described, runs purely on the A7, utilizing obviously the DRAM and the flash and the Wi-Fi, Bluetooth. The M4 is really available to interact with any other third-party hardware that you add into it. So lower level stacks can be run on that, and then those stacks can interface to the main operating system as it can do with any other operating system as Android Things. So Android Things itself, as the binary image that you can download from the Android Things website today, does not utilize it. But by writing user drivers to enable third-party hardware, such as Vince described, such as a GPS module, such as sensors, that data can be cached onto the M4 and then passed to the A7 as you can do with any other operating systems. Now, to fully understand how to do that, there's a number of heterogeneous multi-core white papers and tutorials that NXP have put out there and some of our partners have put out there. So what I would do is I would search on nxp.com and other websites for heterogeneous multi-core processing regarding the i.MX7 dual. The same procedure and the same interactions between the A7 and the M4 are true with Android Things. Because remember, Android Things is obviously Android, therefore you have the Linux kernel and the same process that is available with the NXP Linux distribution. The same principles work with Android Things.
Thank you, Robert. Got a question, I believe Vince might be up your alley. It says security updates are available that you spoke of in your presentation, but what about other OS updates? If they're available, what is the process, both the technical process and the business process for acquiring OS updates?
Right. Good question. So for OS updates, we will provide them as well, but we don't have any sort of guidelines to the OEMs or developers of when they need to push those out. Because the thinking behind this is OS updates, especially Android Desert release updates, might be very disruptive to the end user. And there might be new APIs, and that there might be more integration and testing that are required before it makes sense to push these out. So we don't have any guidelines around those. Security updates, on the other hand, are a little bit more of a concern because when these things go out and the press receives it and people are actively attacking these things, people do want to update their devices very quickly. So those ones we have a regular cadence on, and it's up to the OEM when they want to push it out, but we make those available very, very quickly.
Oh, thank you very much. Robert, we have a question that says, are some of these modules available in industrial temperature range, 40 to 85 degrees Celsius?
So yes, so the Pico modules that I highlighted are available in both industrial, extended consumer, and consumer. They're available. It's the same, obviously it's the same form factor and it's the same die. We just do a different qualification. So if you are looking for industrial, the Pico 6UL 7D are available. I believe the other 6UL that is currently certified by Google from a company called VVDN, the Argon board, I believe that is just an extended consumer. But as Vince talked through, we're looking at the wide usage models of IoT. So as we work with Google going forward and the future parts, i.MX parts we look to get qualified and certified, we will be looking to enable both in industrial qualification as well.
Thank you, Robert. Vince, there's a question that's come in many different forms. Hopefully hopefully you can answer. It says, what if I have an SoC that isn't on the list of supported system on a chip or system on a module devices? How can I get Android things to work?
Yeah, this is a question that comes up oftentimes. And I think it's a good highlight of the difference between AOSP and Android things. Of course, Android AOSP is something that has been available since the early days of Android. The way that model works is, developers are free to take the open source version of Android, customize it to however they like, and then as part of that, it means bring up on whatever SoC, whatever hardware platform that people have. And people do that, and in IoT, this might be more work than people want to chew off, given the volumes in this space. Android Things is really a different model where we want to really make this really easy for people to go from prototype to production, and that's why we went with a slightly different model, which is we work with the SoC NXP directly, or at the beginning, so that we identify the chips that sort of make sense in this space. We're open to supporting more SoCs. This is just the beginning of the journey. And over time, we will have more SoC support. I would encourage folks who are interested in a specific product and they have a specific SoC demands to talk to NXP. And we're open to sort of talking in terms of what the future roadmap may look like and what sort of SoC may make sense to accommodate the wide variety of things people want to make.
Well, thank you. Along the same lines, would there ever be support for microcontrollers? This question's been asked a few times.
Yeah, this question comes up quite a lot as well. And I should emphasize that the way Google Android is looking at this is we're not really trying to provide a solution for all of the IoT use cases on the market, and certainly for low-end devices that usually have do bare metal programming, or people usually put a real-time OS on it. These are not the type of devices that we think we can sort of add value on. Where our solution really shines is when people want to build devices at the edge that have intelligence, that have some sort of processing. And good examples of this are if you want to put machine learning on for example, a smart camera, and you're trying to detect, people or things, and perhaps doing other processing like that at the edge.
That makes sense. The question for both of you, from a hardware and software standpoint, some of these devices may be in the field for 5+ years. What is the long-term support policy for Android Things as well as the products that are supplied by NXP?
So I guess I could start. This is from Google's perspective. On IoT, our understanding is that devices go out and are in the market for 5-10 years, oftentimes maybe even longer than that. And it is our intention to support Android for longer periods of time. We will have more of a clear announcement when we move from developer preview to full launch. That is expected by the end of the year, which we also announced at Google I/O as well. So we'll have more to share in terms of specific how many years and how long will security updates be for example, Android O or P or Q in a couple months.
And on the hardware side, all the NXP parts that we have chosen and will choose for Android Things are part of our long-term availability program. So that guarantees that the part will be available for a minimum of 12 years. And then the partners we chose to build the system on modules and the development kits around those parts, we also chose those partners because they are long-term partners of ours that are focused on the industrial markets and realize that product life cycles are 5 to 10 years, if not longer. Therefore, we have guarantees from them, and they find it beneficial for them, for themselves and their business model, to have those kits available for that same time period. So we are, purely very focused on the industrial market. We believe, that Android things has a lot of potential and will get a lot of traction in our traditional embedded industrial market. So we're choosing the NXP parts and working with partners that will enable for both development and production to support the life cycles that we know exist in these markets.
Yeah, that's fantastic. Thank you both. There's a questions that revolve around adding, third-party devices, and I believe Vince, you touched on this about how devices are added to the Android things system. But can users add kernel drivers to support these, or does Google have to certify them as well? Can you address that?
Yes. So our design is that everything from the HAL layer downwards, so this includes kernel drivers, are all part of the BSP that Google provides and then hosts on our site. We do not expect OEMs or developers to contribute at that level. So we welcome any feedback in terms of things that may or may not work in this model. Our plan is that we will add APIs and we'll plumb through Android APIs that are required for people to do these things that they would usually do. So the example from the peripheral I/O, so that you can access the buses directly. The user drivers that allow you to plumb through things like audio and input and stuff like that. So these are all new things that we've added so that usually you would have to write kernel drivers for these things, and with these new APIs, you wouldn't have to. So if there are things that as people are experimenting with this or building actual products, and you find that you are stuck because you need to do something that is not possible, please let us know, and we really want to hear that feedback.
Thank you very much. There's also some concern about the requirement for quad SPI flash on the processor. Is this and I ask Robert this, is this a requirement by Google, or is this just a suggestion?
So really, in terms of flash, in terms of to enable the over-air updates and other updates that Vince mentioned, we integrate eMMC flash, and that will be the type of flash that we use going forward on all of our NXP-based solutions. One of the questions was, will all NXP parts or i.MX parts be supported? Really, what we do is we work very closely with Google, as Vince mentioned earlier. They are constantly, as we are getting feedback on how people are looking to use Android things, we then work closely with Vince and his team to understand the right parts. We then have to go and find a partner to build that SOM and reference the design, and then Google has to certify it. So it is a process. We're all working as fast as we can. So we have a roadmap where we are looking to get more i.MX-based products and SOMs and dev kits available as soon as possible. But obviously, we have to. Google has resource constraints, as all companies do. So we will see more i.MX parts of currently shipping parts and future parts that will become certified to run Android things, but they will all follow the same structure in terms of flash, which is eMMC.
I can say a bit more about eMMC.
Yeah, please do.
There are quite a bit of benefits with using eMMC. One is that it has security primitives that allow us to do verified boot. So this is the key mechanism that allows us to protect against bad actors changing the image and doing attacks that way. The other thing, as Robert mentioned, we're doing updates, ongoing security updates over many years. And with raw NAND, it is not something that can sort of survive that many write cycles, whereas MMC has built-in sort of controls for managing bad blocks and stuff like that. So there's definitely some benefits with MMC when we looked at which thing to support.
Fantastic. And then a couple of last questions. What is the licensing model to participate with the Android Things platform?
So Android Things is completely free, just in terms of just mentioning cost first. And then the way to access it is there is a developer console that is already available on developer preview. And anyone can go in and download the images for the NXP boards that we talked about, and you can put it onto your devices. There are no additional licensing requirements more than what Android Android has. And the beauty of using these pre-certified modules is that we've pretty much done all the work for folks for certifying these boards. Usually what you would have to do is build your product and then have to certify it as an Android compatible device. You would have passed a full suite of tests to do that. And these modules already, just by definition, they already all pass all of our tests. They're full Android already, so you don't have to worry about that. And that's pretty much it. In terms of the services that run on top, I know that a lot of people are interested in building for example, Google Assistant devices. And these services have separate licensing and agreement requirements. So those are a little bit separate from the platform itself. You can start today with Android Things and build whatever you want. And if you want specific Google services, that's a sort of a separate discussion.
Well, thank you very much. With that, I'm going to there are several other questions that will probably continue to float in, but I want to offer everyone to please use use your Avnet FAEs as well as your NXP account managers and FAEs to try to give you further support through your design journey. Gentlemen, Vince and Robert, are there any last words from you gentlemen before we close out?
Thank you very much for setting this up, and I really value talking to developers directly. Thank you for giving us the opportunity. If there's any questions, please free to flow them into, send them over to me later.
Yeah, I would just add, what we're talking about is not theory. It's live and ready to go now. So as Vince has mentioned, if you go to the main Android Things website, there's a lot of information there. There's already code examples of the peripheral I/O and user drivers that he's mentioned. Obviously, the images are there. And also the hardware. We're not talking about something that is going to be ready in 3 to 6 months. The dev kits and the SOMs that we mentioned are available today. They are in mass production. This is not something that is going to ramp slowly. So you can buy the hardware today. It's cost effective. We're not talking about hundreds of dollars here. You can download the image and start writing code straight away. So I think what we encourage, contact, as Michael said, contact your Avnet FAEs, contact your NXP FAE or salesperson if you have contact with one of those, or simply go and buy, or do it by yourself. Simply go and get the hardware, download the image, start playing around with it. If you go to the other link that Vince highlighted, which is the community, the IoT, the Google IoT community, you'll see lots of Android developers that are already playing around with Android Things, developing applications, and really seeing real-world examples. So this is not something that is moving slowly, it's moving very fast. I suggest you get on the train right now and get your IoT device to market before your competitors. Thanks a lot.